right, welcome back, everybody. Hope everyone's doing okay. I did. Oh, let me let a couple more people in. Okay, I did send an email changing the date of the first exam, simply because we're not going to have enough time between now and Tuesday, which was the original day for exam number 1, to complete everything. Okay, because the first exam is chapters 1 through 3. So I moved it to Thursday, so give you a little extra time to finish up. We'll finish up chapter 2 today. We'll jump into chapter 3, knock that out on Tuesday, and then Thursday, the exam opens up at noon and it stays open until 10 p.m. Okay. Now, for exam days, as I mentioned in email, I'm here, and normally I open the day up to questions concerning the exam. So people go in early, knock it out, some wait, study a little more. So you got any questions about chapters 1 through 3, we can go over it. Okay. If not, I will continue with the next chapter, chapter 4. Okay. Now, in doing this, what this does is toward the end of the semester, we're going to end up with about maybe 2-3, quote, what we call study days. So basically no lecture, no talk about chapters. Those days are totally open up for you to come in with questions. I'm here for the time. I'm here and just, ask any questions, prepare for the final, so on and so forth. Okay. All right. Any questions about that? So, I won't never make any assignment due until we are done with it here. All right. So if I forget to move an assignment over, that's why the schedule says tentative schedule. Okay. Because I do move the days as needed. I'll give you 1 or 2 days after we get it done with the chapter for homework to be due. And if I forget, don't get all crazy about it. They just send me an email, remind me, oh, you forgot to move the day over. Okay. All right. So, and that includes exams. Exams, if I'll move as needed. Probably the first one is the only one that will be moved because the first 3 chapters are a lot of information, short period of time. Other than that, now we're going to get into more of a steady week, chapter per week, approximately. All right. Any questions about that? Everybody understands? No surprises, right? You know where all your stuff is, where you can get help. Tutoring, I sent an email. It was a forwarded email of a tutoring update. If you need some assistance, if that doesn't work out for you, shoot me an email. We can set up time that I can, maybe before class or after class, I can help you there. So you have a lot of resources available to you, okay? Don't get caught at the end really having the challenge and having to withdraw. You shouldn't have to do that. All right, so let us continue. What I'm going to do today is finish chapter 2. We're talking about scientific notation, and then we're going to finish that up. And then I'm going to go into a PDF file that I talked about the conversion factors with respect to the metric system. Can I help go over that real quick? And then I'll give you an extreme example of using conversion factors to go from unit to unit, okay, to demonstrate, even though this is crazy, you see the units, it makes sense, but if you got conversion factors, you can go from apples to oranges, all right, using this, what is called, there's a couple names for it, they call it dimensional analysis, is one name for it, variety of names, I call it keep track of units, plain and simple, don't make things more complicated than they need to be. All right, so let us get into scientific notation, but I want to go quickly to the website, to the Canvas course, because under the announcements, there is some information about scientific notation. In fact, there's a video there too for you to help you out. Get you a head start on scientific notation. Now, scientific notation is nothing more, nothing complicated. It's just the means to be able to write humongous numbers, very large numbers, or very small numbers, okay? To be able to input that into your calculator to do calculations. Now, the basic format of scientific notation is shown here. on the box, okay? Now you have the letter C. Now the letter C, the format is this. You're always going to have an integer. C represents a number 1 through 9, okay? There always will be a number there. Now, normally, if let's just say 1 times 10 to the, I don't know, second power. Okay, so you have a integer here. So this is C, okay? And if you have a number with decimal numbers, let's say you go 1.0, okay? The one aspect about scientific notation is these numbers up front, the times symbol here, always represents the number of significant digits that you need. You remember the rules we talked about sig figs. This one has 2 sig figs. This example here has 1 sig fig, right? Now the format is this. If you have to write more numbers, more than one number, like 1.0, there's only going to be one integer in front of the decimal point. You can have as many zeros as you want after the decimal point or whatever digits you want, okay, after the decimal point. Oh, let me erase this a little bit. I got to work on this resolution. I've lost some resolution somewhere and I don't know why. Okay, and so I could say 1.0048 times 10 to the, for example. So I write as many numbers as I need here, but here's my decimal point. Sometimes I put a decimal point, sometimes I don't, but I put a decimal point because if I got zeros coming, that's going to make those zeros significant. All right, so this number here, the format, the scientific notation, is there's only going to be one number, 1 through 9, followed by whatever comes afterwards, the point, whatever numbers follow that. That is the format. You won't find it like, say, 10 times 10 to the third, okay? You won't find it. That's not the correct format. There's going to be one number, point, then whatever follows times 10 to whatever coefficient. All right, so then we got the times 10. These are powers of 10, and then n is some coefficient. Now that freaks people out. I don't know why, but let me break it down for you. All right, so if I write 1 times 10 to the third power, all that does is, all that tells you is this, it's 1 times 10 times 10 times 10. That's all we've done, okay? When you got these powers of 10, there's the exponent of 1. And when I multiply 10 to the first power times 10 to the times 10 to the first power times 10 to the first power, I simply add the coefficients. So 1 plus 1 plus 1, guess what? It's 3. Okay? And that's all it's saying. So you got the number up front of C times 10 to whatever exponent it is, n. Now that exponent, n, can be either positive or negative. If it's positive, it's a number greater than 1. If it's negative, it's a number less than 1. Okay, so if you look at the first example here, 52,314. Well, the way we convert that to scientific notation, we know that the decimal point is right after point number 1. Before you convert a number in long form to scientific notation, make note of the sig figs, because when you write it in scientific notation format, the sig figs follow with it, okay? So you know that for first example, there are 5 sig figs. So make note of that. I'm going to have 5 sig figs at the end of my conversion of this number to scientific notation. Point number 1. Point number 2, find where the decimal point is. Now, the decimal point may be presented or may not be presented. In this case, it wasn't, but we know it's going to be after the 4, okay? And what we do is it's a nus. So that's point number 2. Find the decimal point so you can determine which direction you're going. Point number 3, look at that number. It is a number greater than 1, right? Okay, 52,000. So obviously we're going to have a positive exponent, that letter n, the exponent n. And we're going to travel from right to left. And we're going to travel and count the decimal places until we're in front of the first integer all by itself. All right, so if we go from here, we're at 4, we move it across and move over to the 5, because we notice the 5 is the last number in this number here. So it's going to be 5.2314, okay, times 10 to the 4th power, because we moved the decimal point over 4 positions, okay? And so this is no different than saying, taking 5.2314 times 10 times 10 times 10 times 10. Multiplying that number 10 by 10 4 times. That's all it's doing, but it's shorthanded, okay? Put in shorthand format. All right, look at the next one, 3.2. The problem is saying here, put that in scientific notation. The thing to put in memory is 10 to the 0 power always equals 1, okay? So we write 3.2 times 10 to the 0 power, which is basically saying 3 times 2 times 10 to 1, okay? All right, also notice before in the first example, we have 5 sig figs, so our answer had 5 sig figs, okay? Hold on 1 second. 5 sig figs, so we're going to maintain that. We got 2 sig figs with number 2. Look at number 3. Okay, first thing we notice is it is a number less than 1. Starts off with leading zeros, okay? And so here, that's a clue to tell you that our exponent will be a negative value, okay? We look at the number and find the first integer, find where the decimal point is, obviously it's up front. We're going to move, instead of from right to left here, we're going to move from left to right until we find the first integer that number has and put that decimal point right after that first integer. So we're going to move from here, we're going to go 1, 2, 3, 4, and 5, okay? So, plus we know there's 3 sig figs in that number 4, 2, and 8. So our answer would be 4.28 times 10 to the negative 5. Note the difference. Everybody shares the format of C. Okay, you got an integer, maybe a decimal point, maybe not. And then if you do have a decimal point, whatever numbers follow. Everybody shares that format. What differs is the n power, okay? And if it's a number less than 1, it will be negative, okay? So this is times 10 to the negative. Now, what does that mean, okay? Well, I'll put it to you this way. Let me erase some of this junk here before it gets too crazy here. Is with respect to, let's say we got 1 times 10 to the 3rd positive exponent, n. So that just means 1 times 10 times 10 times 10 3 times. 1, 2, and 3, okay? And if you got 1 times 10 to the negative 3rd, all that means is just 1 divided by 10 times 10 times 10, okay? See the difference between the exponents? All right. And so that is the format of the scientific notation, where we have an integer followed by whatever's the rest of the number, decimal point, and then followed by the rest of the number times 10 to whatever exponent, be it positive if it's a number greater than 1, negative if it's a number less than 1, okay? Note this big number here, 602 million, right? We start here, we move the decimal point over, we keep going from right to left until we stop right in front of the last integer. Note there are 3 sig figs in that number. So we're going to end up with 3 sig figs. So it'd be 6.02 times 10 to the 8th power. Okay. All right. So let's go back to, oh, wrong one. Just 1 second. Zoom had changed their format, and I'm not crazy about it. Oh, look at this, wrong one again. All right, let's try this one more time. It used to be able to, if you had 3 or 4 PowerPoint slides open, it would tell you which one you're at. Now it doesn't tell you that. Then you got to search. What the heck? All right, I think we got it here. Maybe. Okay. Here we have. My apologies. Bear with me. All right, let me close this up. I got too many things opened up. That one, and that one, and now we got it. All right, there we go. All right, so this is the chapter, the slide we stopped. We have scientific notation and just the means of being able to express very large or very small numbers. Also, it's a means to be able to put these large numbers into a calculator for us to do calculations, okay? All right, so we have these numbers here. The top one's a very large number, and then obviously the number down at the bottom, the second one is a very small number, okay? And so let's take an example. Let's take 93 million miles, which is approximately the distance of the Earth from the sun, okay? And so to put this in scientific notation, first point is note the number of sig figs, okay? 93, there's only 2 integers here. All those other zeros are insignificant. They're not significant digits. There's only 2 sig figs. So our answer will be, we should have 2 sig figs, okay? Second of all, it's a number much greater than 1, obviously. And so therefore our exponent will be a positive value. We find where the decimal point will be, and we count the position until we are at the last, keep going, until we are at the last integer, and we stop right in front of the last integer. And so that is 9.3 times 10 to the 7th power, okay? So again, as I was trying to state earlier, here's an example. Yes, that 93 times 10 to the 6 is in scientific notation, but it's not the correct format of scientific notation. It is an integer either by itself, or it's an integer point, then whatever numbers fall, okay? So don't leave it in that format, put it into the correct scientific notation format, okay? There always would be 1 digit in front of the integer. You know, and this also too gives you a means to write numbers in the correct format. For example, if you have 1,000, the number 1,000, and you're asked the question, and the question says, write 1,000 in with 2 significant figures. Well, you think about it, you know, you really can't, okay? Because obviously, if I put a decimal point in 1,000, now I got 4 sig figs, so that won't work, right? And the way it's written, 1,000 is only 1 sig fig. The zeros don't count. So the only latitude I have is to convert that number 1,000 into scientific notation, because the number in front of the times always represents a value, a number with the correct sig figs. So if I take 1,000 and I write it in scientific notation, it is 1 times 10 to the third. And if I need to make that number with 2 sig figs, guess what? I just put 1.0 times 10 to the third. I got 2 sig figs. So in that manner, when you ever doubt how to write a number with the correct sig figs, convert it to scientific notation, okay? Convert it to scientific notation, and that number in front of the time symbol will always represent the correct number of sig figs. All right, let's do this. Now, let's take a small number, the radius of a carbon atom, which is pretty tiny here. Okay, very small. So 0.00000, etc., 17 meters. Okay, very small number. Okay, so point number 1, note the number of sig figs in this number. So we got 2 sig figs. So we keep track of that because our answer is going to have 2 sig figs. All right. Second thing, notice something, that this is a number much less than 1. Therefore, our coefficient, or to the n power, will be a negative value. So here's our decimal point right here. We go, in this case, from right to left, and we travel until we stop right after the first integer, in this case is 1. And so it becomes 1.7 times 10 to the negative 10 meters, okay? Negative 10 meters. So that's a very, very small number. Yeah. All right. So notice when numbers greater than 1, we're moving from right to left. In this case, we're moving from left to right, and our exponent is negative. So in this, excuse me, in this example of questions here, they're asking you to convert the following into scientific notation. Follow a format. I'm a big advocate of a specific stepwise procedure until such a point that you become proficient and you don't have to go through that. But in the beginning, until you're comfortable with it, take a stepwise your problem solving here. Okay, you know, I know very few people who, when the first time they got on a 2-wheel bicycle, like training wheels, jumped right on it and did not crash. Okay, you steadily jumped on that bike, and until you became proficient that you're driving down a highway with no hands on the wheel, on the steering column, right? It took time and practice, and so time and practice, we go through the stepwise procedure, and you become very proficient in doing these problems. So step number 1, determine how many sig figs you have. Okay, so number 1 has, how many sig figs does number 1 have?
6.
You got it, 6 sig figs. So I got to keep that in mind. So exactly, okay, I got to keep that in mind. So when I have my answer here, I maintain 6 sig figs. All right, then I find my decimal point. Second thing I note is it is a number much greater than 1. Okay, all right, well, that tells me my exponent is going to be positive. Okay, then I got to find the decimal point. So there it is, right there. And since it's a number greater than 1, I'm moving from right to left until such time I stop in front of the the last integer, which is the 5. So I got to move the decimal point in front of the 5. And in this case, it's got to be moved 2 times. Okay. And so that becomes 5.48005. I don't lose my sig figs. Okay. I still got 6 there. Okay. Times 10 to the 2nd power. Okay. See how that worked? All right. How about number 2? How many sig figs do we have in number 2?
3.
We got 3. So our answer is going to have 3 sig figs. Okay. And that means that the 6 and the 8 and the 1 are going to be there because the zeros are not significant here. Okay, they are significant with respect to value. Don't want to confuse the term. I wish there was a different term to use in sig figs, but that's the term they utilize. Okay, so we're talking about significant with respect to do they count when we present the final answer if I do some mathematical thing to it. If I multiply, divide, I subtract, okay? But it is significant with respect to value, insignificant with respect to accuracy and precision. All right, so we got 3 sig figs. The decimal point is right, obviously the last 0. I got to move it from right to left because it's a number greater than 1. And in this case, I'm moving it how many places? What does my exponent amount to here? Anybody know? I'm starting here. 7. 1, 2, 3, 4, 5, 6, and 7. I got to stop in front of the 6. So that becomes 6.81. Still got 3 sig figs times 10 to the 7th. Okay. All right. Next one, number 3. Find out how many sig figs do I have in number 3?
3.
You got it. Remember, these are leading zeros. The first, the 0.000 are leading zeros using the straight rule of sig figs. Or if you forget that, ask those 2 questions. Is there an integer in front of those zeros? The answer is no. So they're insignificant. Okay. If you answer no to any of those 2 questions, is there an integer in front of that 0? Is there a decimal point anywhere in that number? No to any of those answers makes those zeros insignificant. Okay, they're just value placement points. And so we have 3 sig figs, which is the 400, right? And obviously, that's supposed to be a 0. Obviously, we're going to have to start from this decimal point and move over from left to right, 1, 2, 3, 4 positions until we stop right after the first integer, which is the 4. So it times 10 to the negative 4. Okay, because again, this is a number less than 1. So that exponent will be a negative value. And then 2000, we only have 1 sig fig here. The zeros don't count. And so we just simply, like we did number 2 is with decimal points right here. We got 1 sig fig, so it's going to be the 2. So we go 1, 2, and 3 times 2 times 10 to the 3rd. Okay. And that is the number 2000 converted into scientific notation. If we needed to write 2000 with 2 sig figs, we simply write 2.0 times 10 to the 3rd. If the problem said write 2000 with 6 sig figs, guess what? 2.0, 1, 2, 3, 4, and 5, 6, right there. That's the number 2000 written with 6 significant figures. Okay, so that's the advantage of scientific notation. You can put it in any number of sig figs you need. All right, so here's the answers. And don't forget the units, obviously. I forgot the units to write them down. Okay. All right, now how do we input them into the calculator? Well, there's 3 formats, at least the last I checked, and depends on the calculator that you have. Let me go to the next drawing. Now, if you're using the Windows calculator, you will find a button labeled EXP, which I circled here on the far right. This is the Windows calculator. Okay. So EXP is a button that you need to be familiar with. The other button you need to be familiar with, a couple of formats, depends on what you're using, but in Windows, there's a plus/negative symbol, and that's just your toggle to put you into positive, negative, because sometimes the number, the integer could be negative, or obviously the exponent could be negative, and hitting that button toggles it back and forth, okay? So the Windows has an EXP button. Some calculators have a button called EXP. There are other calculators. This is a double E. I circled over here, double E. Here's a button labeled EE, okay? And for this calculator, the toggle button is something that looks like this, the toggle for the positive and negative. So find on your calculator the button to toggle back and forth. Now, these buttons here are primary buttons. Some calculators can make the EE or the EXP a secondary function. Okay, so be careful of that. If it's secondary, then obviously it's written, like in this case, the yellow button. And to access those, you got to hit the second button. Okay, here's the second button in this calculator. So check it out on your calculator. Look at your manual to find out which buttons. I'm sure there's some examples of how to use scientific notation. And if you're still having challenge with it, shoot me a screenshot of your calculator, and I can help you out. Now, the newer calculators, oh, somebody had a question. All right, 7, yeah. The newer calculators have a button. If you notice, it's in blue here on the first image. It says times 10 to the x power. You see that, Hal? Okay. Again, most of the newer calculators that I was seeing have the blue, the one right here, button, okay? Now, that is different than taking a number like 2 and then hitting the times symbol, and there is a button in calculators that have a 10 to the x power, okay? And some students are tempted to say, type the number, then hit the times table, and then hit that button that says 10 to the x. No, don't do that. That is not scientific notation, okay? Scientific notation will either be EXP, okay, double E, or X 10 to the x power, okay? Totally different ball game if you use the button that's by itself. There's a button all by itself that says 10 to the x power. Okay, do not, that's not the correct button. Whoa. Okay, that's not the correct button. Oh, I still messed up. Get up. Okay, all right. So check out your calculator. Make sure you're familiar with which button it is that you need to utilize so you can calculate scientific notation. Now, you will need a calculator, because remember, when you're taking exams, we do take note of the log. Exams only, it's the only thing we check. The other homework and stuff, you can pop back and forth with whatever site you need to help you out. But with exams, we take a closer look. And if you toggle back and forth on your calculator on your computer, sometimes it pops up as you're looking away from the exam. So have a calculator, a real cheap one. You don't need to purchase any $100 calculator. I'm sure you will use it throughout your career. I still got my calculator that I purchased back in the 70s. I'm still using it. So it's still good. So anyway. All right, so scientific notation, have your own calculator and so forth. We're going to input this number, and here's a number. We're going to take 2.84 times 10 to the 23rd, and we're going to divide it by 7.24 times 10 to the 12th. Now, what I'm going to do is share my calculator. And I'm using the Windows calculator, so that is what I am utilizing. And where'd he go? Okay. All right, it's not allowing me to do this window. Wow. Zoom is not allowing me to share my calculator, which is not good. Let's try this again. Share my screen. Nope, I don't even see it as a choice. No. Let's see if it allows me to. No. Okay, well. I'm gonna talk to Zoom about that. That's nuts. It won't let me do that. Okay, well, basically, try this on your calculator. Hopefully you come up, first note this, it's a mathematical problem. You are dividing, therefore remember, divide, multiply, think sig figs with respect to your final answer, okay? Not decimal places. Decimal places are for adding, subtracting. So plug that number into your calculator. You type in 2.84, hit that button, whichever button of those three buttons you have, okay? Then it will, depends on the calculator, it will give you something like, it might show you times 10 to the 23rd in superscript, the exponent, depends again on your calculator, or it will give you 2.84, and then because of the calculator being what it is, it would present on the LCD screen, maybe the letter E, and then 23, something like that, okay? So check that out in your calculator. Now, that is not scientific notation format with this letter E. That is just the calculator presenting what you input into the calculator, value-wise, all right? So you type in 2.84, then the scientific notation button, then you type in 23, okay? And then it puts it in this particular format. Now you hit the divide symbol, okay, and repeat the process. Input 7.24, hit your scientific notation button, whichever one it is, type in 12, and then hit the equal, and you spit out a big number. Since we have 3 sig figs here, 3 sig figs here, we should have only 3 sig figs in your answer. Now, it might present this number 3.92 with the letter E and then 10, okay? Because it, depending on the type of calculator you have, it may not show the format of scientific notation. It will show you the letter E and then 10. Well, that 10 means the exponent of the power 10, okay? So convert what your calculator shows into the correct format, which would be 3.92 times 10 to the 10 exponent, okay? Clear as mud? All right. And this is what sometimes either has the letter E or maybe it just puts the exponent like this number here, 1.234567889, and then just shows the 8, which represents the coefficient. But that is not scientific notation. It's telling your calculator is just telling you that is the exponent. And so you need to take that number to put in the correct format. Because if I take 1.23467, and what that means, the way that is written, is you multiply this number by itself 8 times, okay? Totally different than 1.2345678 times 10 to the 8th power. Okay, totally different. So don't look at the format of your calculator to make sure that you're aware of the correct format of your answer, aware of the correct format to input that number into your calculator. Okay. Let me back up. If, for example, this was a negative, let's say negative 12 here. Okay, no big deal. When I type in 7.24 and then my double E button or my EXP button or whichever button I have, it will input the 7.24. Then I can type in the 12 and then I hit that toggle button. The toggle button to convert that 12 into a negative 12. Okay, and you'll see it displayed as a negative value. So if you need to put in a negative value. All right. So any questions on this? Because we're like 2 pages and we're done with this chapter. No? Well, practice with scientific notation. We will be using a number quite a bit down the road. That we're going to be using 6.02 times 10 to the 23rd. This is just a number, an Avogadro number. I think I mentioned this to you before. If you were to count that number, imagine that 6.02, move that decimal point over 23 times. That's how big that number is. And if you were to count one number per second, it would take a few thousand years. I'll see you in a few thousand years when you get down to the end of that number. It's pretty big number. And that's how many molecules there are in what we call 1 mole of atoms or 1 mole of molecules. Very, very important number that we will use. So that's why we use scientific notation there, because we do calculations using that big number. Okay, percent. I think you got this one already. All right. This is analogous to, okay, you got a 100-point exam. Okay, you score, you get 80 correct. Obviously, you got 80%, right? Right? And so you got the part over the whole times 100. And so for that exam, the whole is 100 points. The part is what you got correct. So 80 divided by 100 times 100 gives you the percentage. And that's a straightforward calculation with respect to percent. We can utilize that to say, let's calculate the percent gold in a ring that has a mass of 239.45 grams. Okay, it underwent analysis. It's determined that of that, 198.38 represented pure gold. So what is the percent of gold in this particular ring? All right, so we have the whole, which is the mass of the whole ring, okay, with 239.45, and the amount of actual gold is 198.38. Okay, so we divide those numbers times 100. Okay, now keeping aware of your sig figs, notice that we have 5 sig figs in the numerator, 5 sig figs in the denominator. And yes, our calculator will whip out all these numbers and we might be tempted to put that number down, but that is not accurate. Okay, because you're only accurate to the least accurate measurement. And in both cases, the numerator and denominator have 5 sig figs. So you need to truncate at the 5 sig fig position, which starting from the far left number, moving to the right, which is the 8 right here. This is where we round that number, either going to stay 8 or go up to 9. And we determine that by looking at the immediate neighbor. We don't care about what's down the road. The immediate neighbor is a 1. Therefore, that 8 remains an 8. Okay, so our answer is 82.84% with the correct significant digits. All right, so that's so much for the percent over whole. that is the end of the chapter. Now, what I want to do very quickly is to go over some other things that let me pull up the slide. Okay, I want to go over the file that I have. Where'd it go? Okay, in chapter 2. And let's make sure we're on the right. All right, on the website, there is a file that you will help you. I will help you out with respect to the prefixes. Okay, there are some challenges. I talked about this briefly. The letter C, D, M, and then that symbol looks like a U is for the micro. Okay, I got them highlighted here in red. So the first column is a mass. So we have 1 kilogram is equal to 1,000 grams. And like I mentioned, to help you out, the D represents how many years in a decade, which is 10 years. So there are in 1 gram, 10 decigrams. C represents century, 100 years in a century. So there are 100 centigrams in 1 gram. And M represents a millennium, which is 1,000. There are 1,000 years in a millennium. So in 1 gram, there are 1,000 milligrams. And then the symbol that I introduced was that it's a U with a little tip up front. That's called the micro. There are 1,000,000 micrograms in a gram. Okay. Now we can take those prefix letters and just move them over to volume, which is liters. So we got liters. 1 kiloliter is 1,000 liters, just like 1 kilogram, there's 1,000 grams. Okay. 10 deciliters, 100 centiliters, 1,000 milliliters, and 1,000,000 microliters. Okay. Move it over to the next column, which represents length, which is meters. In 1 kilometer, 1 click, there's 1,000 meters. Okay. And 10 decimeters, 100 centimeters, 1,000 millimeters, and 1,000,000 microliters. So if you had a yardstick, imagine that in a yardstick. Okay, in that yardstick, you have 10 decimeters, 100 centimeters, or 1,000 milliliters, or if you can see them, there's 1,000,000 microliters in that yardstick. Okay, now every one of these things, and this is just a metric unit, is a ratio. Okay, so for example, 1 kilogram is equal to 1,000 grams. I could write it either with kilogram in the numerator or kilogram in the denominator. Which one I use depends on the question asked, okay? Because I'm going to follow my units to cancel these units. And if I got them set up properly and I'm canceling my units, do I know what units I'm looking for at the end? I got the problem set up properly, okay? For example, how many micrograms are in 0.125 kilograms? We can set that up as follows, okay? We are given, we write down what we are given, which is 0.125 kilograms. And I also at the end, and I'll show you some more examples of this, write down the units that I'm looking for, because that helps me map my route to where I need to go to. I'm looking for micrograms. I begin with kilograms. So I need conversion factors. One, the first conversion factor, I need to get rid of the kilogram. So I know that in 1,000 grams, there are 1 kilogram. So this first conversion factor, guess what? Gets rid of my kilograms, leaving me grams with grams, units, okay? But it's not where I need to go. I need to get to micrograms. So obviously I need to have another conversion factor that gets rid of my grams and leaves me the units that I'm looking for. All right, so I know that there are 1,000,000 micrograms in 1 gram. And so I'm keeping track of my units, my grams cancel. Now, unit-wise, all the units have canceled. I got the units left over of micrograms, which is what I'm searching for. So that tells me I got it set up properly. Now, earlier I said, you may want to change these numbers. Don't do that. If I need 1,000,000, write the 1,000,000 in the numerator or write it down in the denominator as that. Don't try to take the inverse of that if you got to invert it. It just mumbles up the whole picture. Okay, just leave the numbers where they're at and just flip them back and forth as needed. So now, by checking my units, keeping track of my units, I am at the units of micrograms, and now I can simply just do the math. So I just put my calculator in 0.125 times 1,000 times 1,000,000, and that is my answer. Okay. Now, might keep track of your sig figs, 3 sig figs. So I gotta have it. Fortunately, it ends up with 3 sig figs at the end. These conversion factors are exact numbers. Okay. There's exactly 1,000,000 micrograms in 1 gram. Okay, so being exact numbers, they don't play a factor with sig figs. Remember that. Okay. So any ratio, anything that we give you that you see there, we can set it up as follows. Like we give you these 3 conversion factors. You'll find that in the shapes table. And 1 inch is 2.54 centimeters. That's given to you. You don't have to memorize it, but it's there. Okay. 1 pound is 458 grams, 54 grams. 1 quart is 946 milliliters. Now you'll be tempted to go Google it. And yes, you're going to get numbers with a lot of decimal points. My suggestion is don't do that. Why? Because Canvas is set up to give you the answer based on these numbers. Okay. So use these numbers. The one difference is this, and this is something to remember. Of these 3 conversion factors, okay, the only one that's considered exact is the first one. Okay, that is by convention. I don't agree with it 100%, but I got to follow the rest of it because it's a measurement, but it is treated as an exact number. What they're telling you, there's a 1 answer is exactly 2.54 centimeters. Okay, well, we'll go with that. The other 2 are not exact. Okay, so that means that if you, let me learn how to spell here, not exact. The pound to grams, the quart to milliliters are not exact. What that means is they could be a factor with sig figs. Okay. And obviously the number 1 is exact, but the 454 is not exact. There's 3 sig figs. The 946 is a measurement, and therefore it could be a factor in sig figs. And be careful because some conversion problems in there, if you present the wrong sig figs, you probably presented it's wrong because you didn't remember that these 2 are not exact and could be a factor with respect to your final answer in the correct sig figs. Okay. All right. And so all these ratios, conversion factors, can be written as ratios as given here. And that's true for any ratio. Okay. $50 per hour. I can write it as 1 hour per $50. Okay. 100 miles per hour or 1 hour per 100 miles. And so obviously if I said to you, all right, you're working at $50 an hour. Okay. You're working at $50 an hour. I need $1,000. Okay. How many hours do I have to work? All right. So I'm using the technique of what we're going to be utilizing here. So I need $1,000. And I'm sure you got that worked out in your head already, but I'm working at longhand. I write down what I'm given, and I write down unit-wise what I'm looking for, hours. I'm looking for hours, okay? I know I'm going to have a conversion factor here, all right, which happens to be the one I'm going to use is the one on the right, because why? I'm looking for hours. So I need hours on top, and I need dollars in the bottom. Okay, because my dollars cancel out. Okay, so 1,000 divided by 50 tells me how many hours I got to work, 20 hours, so I can make $1,000. So that is this dimensional analysis technique of how we utilize and how do we use our units to follow through the problem to make sure we set that up properly. And I guarantee you, 99% guarantee that you follow that, you don't have a problem. I can't control you pushing the calculator, like I stated, and so, but if you use this technique, when we get down to chemical calculations, it's going to come in very handy. Basic algebra, remember this, that units cancel here to help you out. We went through this, a squared is nothing more than 8 times a, so I can have a set of a's cancel, so on and so forth. All right, so that brings us to the infamous crazy conversion thing. All right, now this is, I've had this slide for a number of years. Back when I was teaching at Carrington College, dental hygiene students needed chemistry, so I had to teach them. And there was a challenge with respect to what we've been doing, conversion. And I just made up this conversion factor question to demonstrate that if you have conversion factors, you can go from apples to whatever if you have conversion factors. And this is analogous. So you're going to be having chemical problems that where you're going to be looking at X amount of product or reactant, and you go, well, how am I getting to product here? All right. Well, we'll have conversion factors. So let me do an extreme example. Here's a given the following conversion factors, how many DH students, dental hygiene students, equal to 4.5 bananas? Okay. Kind of crazy, huh? All right. All right, that's the situation, right? So here's the deal. Question is, what am I looking for? All right, I got 4.5 bananas I'm given. I'm looking unit-wise DH students. So I set up my problem. So this is what I'm given unit-wise and value-wise, and this is what I'm looking for unit-wise. We're going to calculate that. Obviously, we put numbers. I know that I'm going to need conversion factors here, okay? And those I'm given right here. I'm given the conversion factor that 1 DH student is equal to 6 grapes. And that 3.5 grapes is equal to 1 orange, and 1 orange is equal to 6 toothbrushes, and 3 toothbrushes is equal to a banana. I got 1, 2, 3, 4 conversion factors, of which I can write as a ratio, okay? All right, so let's set it up. And so there's the same information. And the first thing is we're given, and keep it in mind that what I'm looking for at the end of the day, as they say, is how many DH students I need at the end, okay? So that's where I'm at. All right, so I'm given 4.5 bananas. I need a factor, a conversion factor that gets rid of bananas with respect to units, right? And I'm given one right there. I know that I got 3 toothbrushes to 1 banana. And so if I set this up like as follows, at this point, unit-wise, I have toothbrush. Am I where I need to be? Obviously not. I got to get to DH students. So that tells me I must need some more conversion factors, right? So I need a factor that gets rid of toothbrushes now. I just got rid of bananas. All right. My first one was bananas. Okay. My other factor is that 1 orange is equal to 6 toothbrushes. Okay. 1 orange and toothbrushes. So here are the conversion factors right here. Okay. I can write them any way I want. And how I write them depends on what I'm trying to get rid of. So now, if I were to stop the calculation at this point, then my answer would be in the units of orange. I don't care about the numbers right now. I'm just looking at my units. I'm following my units right now. If I were to stop right now the calculation, I would be in the units of orange. But is it where I need to be? Obviously not. I got to be DH students, okay? So I got to find one more factor to get rid of orange and get me into something else. I know that, again, by the conversion factors I'm given, these factors I can neither be given or I know them because, like 1 inch is equal to, 1 centimeter is equal to 2.54 inches, those kind of factors. I'm given another factor here where I can get rid of oranges. So now I'm in grapes. So imagine that. I went from bananas to toothbrushes to oranges. Now I'm in grape with respect to units, okay? I'm still not where I need to be with respect to units. I need to be in DH students, so I got one more. So finally, I got my last unit. So notice I set up 4 conversion factors here, okay? I didn't invert the numbers. I left the numbers as is, so there'll be no, did I invert that or not? Or, just leave the numbers, plug them in whole. Okay, so double check yourself, go back, I set this up. This is an example also of showing your work. If you ever need to present something that says, show your work and I want to convert apples to oranges, okay? All right, now, as I do that, I check my units, and guess what? Unit-wise, I am now in the units that I need to do. So now it's just a matter of doing the mathematics, okay? Now, I've been asked the question, does it make a difference in this math here? If I take 4.5, do I have to multiply all the numerators together and all the denominators together? And then, and my answer is this, it depends on your calculator, okay? And one way to find out is this. If you take 4.5, you multiply it by 3, and then hit the divide, and divide by 6, then hit the multiply by 3.5, and hit the divide again, and hit the 6, hit the equal, see what your answer is, okay? Now, do it again, but this time, after each factor, hit the equal. So 4.5 times 3, hit the equal, and then divide by 6, hit the equal, multiply by 3.5, hit the equal, then divide by 6, and hit the equal. Hopefully your calculator understands the mathematical functions you inputted, and the answer is the same in both means, okay? If it's not, go back and double check because your calculator may not understand, I gotta hit the equal, and it's not doing that internally. So double check your calculator. But if when doubt, hit the equal after each factor and then multiply, divide, whatever for the next factor. You always get the correct answer. All right, so at this point, you end up with 1.3 DH students. So the answer is this, 4.5 bananas is equal to 1.3 DH students, all right? Extreme example. Okay, and I did that on purpose because I know when we get into a chemical reaction, you might want to, what do I mean by that? Okay, here's an extreme example that you will be familiar with time. Methane plus oxygen will end up to give me carbon dioxide plus H2O, water, okay? Now, if I start off with 10 grams of methane, how many grams of water I'm going to make. So we got this going to this. And that right now it is apples going to oranges, okay? But there are conversion factors here that will connect us from this reactant to this product. Or the question could be, I need to make 100 grams of water. Okay. How many grams of oxygen do I need to react to make 100 grams? And this kind of calculation is done every day, even in industry. You know, when I used to make compounds, I used to determine, well, how many, I need to make 50 grams of this material. How much starting material do I need to start with? And it's be it I make it in the lab, or be it I make it in some industrial tank building where I'm making this in tons, same basic chemical ratio and calculation is done. The only difference, obviously, in the lab, I got 10 grams, I'm moving it by hand. Out in the field, that's where the chemical engineer comes into play. I got to move 10 million gallons, and it's a totally different ballgame. Okay, so that is the purpose of this. Let me stop here for example, of showing you that extreme example. Okay. And to grasp the idea of using my conversion factors, because when we get in, we're going to build to that equation that I just showed you. We're going to get to that slowly. We're going to talk about we're going to start with the elements. And from the elements, we're going to make the compounds. Then the compounds are going to start reacting with each other to make these products. We have different types of reactions. And then we have to balance them, meaning that if I start off with 10 grams as a reactant, I need to end up with 10 grams as a product. And by balancing coefficients in front of the reactants and products. And guess what? Those coefficients in front of them are the ratios that we're going to utilize to go from point A to point B. Okay. All right. So why don't we stop it at here, and we'll continue with chapter 3 on Tuesday. Okay. Any questions? I got 408. I don't want to really jump into it. It won't take long with the chapter. The next chapter is fairly short, about 25, 6 slides. Okay. All right.